Notes, we're going to learn how to divide right triangles into smaller subtriangles and then use proportions to find missing sides. So in this image we have a large triangle, EDG. And if we wanted to draw that picture down here without all of the confusing stuff inside, EDG, you'll see that we kept 10 where 10 is, 6 where 6 is, 8 where 8 is. And all of the letters are the same and the right angle is in the same location. But there's two more triangles in here. The triangle that is created by this perpendicular bisector creates two more triangles. So the next triangle that we're going to look at is DFG. So that's right here, DFG. So if we were to take this triangle and flip it around, we could draw this triangle. Now it's super important to make sure that you're matching up all the triangles so that they're set in such a way that you can see that this side corresponds to this side. This side corresponds to this side. The hypotenuses all correspond to the hypotenuses, and I think that's the easiest way of doing it. So if I know that my hypotenuse is 8, I know that I want to draw my hypotenuse like this with the right angle across it. That means x is our longer leg, and this segment, which we don't know the value of, is our shorter leg. So you want to make sure you orient the triangle to look the same. Our last triangle is the littlest triangle. So we're going to look at this guy here, EFD, which is down over here. So again, I'm first going to figure out, okay, where's the right angle? Here's the right angle. I know that this has to be 90 degrees because this is 90 degrees. It's a straight line, 180. So that has to be the right angle. Across from the right angle is my hypotenuse, which is 6. So I'm going to set it up so that my hypotenuse is here. My shorter leg is EF. My longer leg is EF. So I want to make sure that that is oriented to line up with the longer legs. And my shorter leg is X. So I want to make sure that that lines up with the shorter legs. So again, this will be the long leg, long leg, long leg, short, short, short. And you'll see that maybe you could argue like that this is short and this is long. As long as you say that these are all the long legs and these are all the short legs, it doesn't matter which one you define as short or long, as long as you're consistent. Therefore, this is the hypotenuse, this is the hypotenuse, and this is the hypotenuse. And the labeling is going to help us when we fill out our ratios down below. So because they're all right triangles and they fit inside the same right triangle, we should be able to prove that these are similar. And if they're similar, we can figure out what x is. Because if these triangles are similar, that means they all have a ratio or a common rate amongst them. So let's fill out the table below. The shorter leg of triangle RTS, so we want to figure out where these are incorrect. Let's change these. So the first triangle we're looking at is triangle EDG, and then we're going to be looking at triangle DFG and triangle EFD. So first change those, my mistake. And now we're going to fill in the ratios. So EDG, that's the yellow triangle, the shorter leg over the hypotenuse. So the short leg is 8, the hypotenuse is 10. So I'm going to do 8 over 10. So we're going to just keep focusing on EDG. The longer leg over the hypotenuse. The long leg is 6, so 6 over 10. And the short leg over the long leg. Short over long is 8 over 6. We're now going to look at the green triangle, DFG, so short over hypotenuse. Short, we don't know, over hypotenuse. So we're going to call this FG. So FG over 8. Long leg over hypotenuse, the long leg is X, the hypotenuse is 8, so X over 8. And then the short leg over the long leg, so short over long. So again, FG over X. We don't know what it is. We're now going to look at the smallest triangle, which is EFD. This is going to be the short leg over the hypotenuse, so the short is X over 6. Long over hypotenuse is going to be long. We don't know this, so we're going to call it EF over 6. And then short over long, X over, again, we don't know this, so we'll call it EF. So now that we've filled in everything that we can about the ratios, we're going to cross out the things that aren't going to help us. This is not going to help us. I can't not know what this is. We're trying to figure out what X is. We can't have two unknowns. So anything that has EF in it or FG, I'm going to cross out because it's not going to help us. I'm now going to look at the columns because these are the proportional relationships, the proportional ratios, right? So I know that comparing short to hypotenuse for this triangle and this triangle is going to give me an answer. So we could set up 8 over 10 is equal to X over 6. We could also look at this column because we have 6 over 10 and X over 8. We should be able to get the same answer both times. This column is not going to help us because 8 over 6 isn't proportional to anything that we can use because there's too many unknowns. So now we're going to do something where we need to figure out, oops, that should say 6, what X is. So you might have learned cross multiplication in middle school, you might not have, but there's two ways to solve this. I'm going to use cross multiplication because I think it's faster. Cross multiplication is when you multiply the things across from each other when they're in fractions with an equal sign in between. That's the only time you can do this. So 10 times X gives me 10X, and 8 times 6 gives me 48. We then can divide, and we get X equals 4.8. In this one, we could do cross multiplication again, or we could use the method that you also learned from middle school, where we want to get rid of the 10 because it's dividing. So the opposite of division is multiplying. So we can multiply by 10 over 1, and those cancel. And then we multiply by 10 over 1 here. So this is going to give us just X. This will give us 60 over 8. And 60 over 8 gives us 7.5. So these are different. This is different than what I had originally said. So which is the correct answer? So if we look back at my work, we'll see that I made a mistake on this one. Here, I should have put 6 over 10. I set up my fractions incorrectly. So the reason why we didn't get the right answer for this one is because I made a mistake of switching my numbers. If we go back and solve this properly, 6 over 10 equals X over 8. Again, we can multiply to get rid of the denominators, and we're going to get X equals 48 over 10, which gives us again 4.8. So you'll see that when I solved both of these, I noticed that they were different. What did I do? I went back up and I checked my work. My work was wrong. I set up this fraction incorrectly. I switched my 6 and my X, right? I swapped them because I was doing the work too fast. So the reason why it's good to set up as many proportions as possible is to make sure that you've done it correctly. Once I went back and checked my work, I was able to get the same answer twice. So we know that X is equal to 4.8.